Today we will plot the influence lines for arch, and we know very well that in a arch, either it is 2 hinge or 3 hinge, either it is 2 hinge or 3 hinge, major force considered at any section X, at any section X horizontal and this Y, at any section P X Y, we have three type of forces. Like if we analyze this segment, say this is A, this is B, and say this point P, if load is certain type of load is acting in this arch, then this reaction it come VA, its reaction VB, its reaction H, its reaction H. Horizontal reaction at point A and B will be same, because load acting on that arch is only vertical load. And at this point P, what are the forces acting, that I want to tell you. At point A, at point this P, if I am going to make the free body diagram of this AP segment, therefore at here is a vertical force VA, this horizontal force H, and at this point forces acting, it will be vertical force acting will be VP, and horizontal force it will be HP. Okay, and value of VP it will be it can be value of VP. What will be the value of VP? Definitely value of VP will be value of VA minus any load on that part. It may be a summation of all forces on AP segment, W on AP segment. If this W AP load due to this external load on the segment AP, if it is 0, then it will be value simply VA, and simply HP, value of HP due to summation of all forces along X direction, it is 0, therefore the value of HP will always be H. So these are the forces acting at that point P. Okay, now since it is in curve shape, since it is in curve shape, if we want to it is in curve shape, and if we have this tangent P, this tangent at that point, tangent and normal to that. Okay, so since the forces whatever we are considered for design purpose, they are we are considering the forces along the axis and perpendicular to that. Therefore, the force which is acting along this direction, it is called as basically normal thrust. Represented by N. And similarly, the force which is acting in this direction, this is called as radius here. Say this value is S. So the N it is what? Normal thrust, and S, it is the radius here. Here. Okay. Now, apart from that, another type of force? They may be rotation type of thing. So the forces acting M, it will be bending moment at point P, at any point, at point P. The forces to be considered during the design, these are basically three type of forces. First is bending moment, radials here, normal thrust acting in that direction. Okay. If we know the value of H, if we know the value of VA acting in this arch, then the value of normal thrust and radial shear. We can find the normal thrust and radial shear by simply by resolving this part. If this is the, it will represent the slope theta, and its value will be tan inverse dy by dx. It will be tan inverse dy by dx. If this is parabolic arch, if it is parabolic, then we know what is the value of, what is the relation between y and x, this y and x. So y and x, it is 4h. What is h? If this rise, if rise is h, so 4h by L square, h times of L minus h. So this is the relation between x and y. Therefore the slope at any point can be calculated by differentiating this equation and putting the value of x and y, respective value of x and y. So calculation of theta is not a big problem. It can be calculated very easily. And after knowing that value of theta, we can resolve the value of HP and VP acting at that point. If we will resolve, then this value will be also theta. And further, if I extend this, then this value will also be theta. Now the forces acting this resolved component of this vertical part VP, at that point it will be VP cos theta. It will be VP cos theta, and the force acting the resolved component of this VP along that direction, it is VP sin theta. It is VP sin theta. Okay, and if you resolve this horizontal force HP, means here HP, if we resolve this force HP, then at that it will be resolved in two parts, this component plus this component. So this component of this part HP, it will be HP into cos theta, and that part will be HP into sin theta. Therefore therefore normal thrust N, can be written as, normal thrust N can be written as, what is that? It is HP cos theta plus VP sin theta, and value of radial shear S can be written as HP sin theta minus VP, this is VP, basically VP cos theta, and value of bending moment at any point, we know very well that this value is mu minus h into y. We know very well bending moment at that point. What will be that value? Bending moment at that point, it will be VA. It will be VA into this horizontal distance minus any moment due to external load at this point. This is called as value of mu, and one more component h into this part y. So it is h mu into hy. Therefore, and these are the parameters, and these parameters can be calculated for moving type of load if we know the concept of influence line. This parameter can be calculated very easily for moving type of load, and that is concept of IL. So my today's concern is to plot all these three values N, S, M, and one more thing that can be these three parameters cannot be determined before this value. If we have that value of h, then we can calculate this three parameters. Therefore, today's concern is to plot number one. Today's concern is to plot number one IL for IL for h, which is horizontal thrust. Second concern, my second concerns of today is to plot. Second one is to plot IL for which one? IL for M, bending moment mx at any point x is equal to a. Okay, x is equal to a. That can be any section. Second one, third one concern, it will be today. My third one concern will be IL for n, and last one we will plot IL for which one? S. Radial shear. Okay, so we will start one by one. We know, and today we will consider the arcs as either 2 hinge or 3 hinge. 2 hinge or 3 hinge. So I will plot all these parameters, IL for all these parameters, for 3 hinge arch and for 2 hinge arch. We know very well that 3 hinge arch is statically determinate, and 2 hinge arch is statically indeterminate of order 1. Indeterminate of order 1. Therefore, we will first of all we would like to plot IL for H. We would like to plot the IL for H. We would like to plot the IL for H. Now I am going to plot IL for H. Okay. Now in this part I will consider the first of all I will consider the case of 3 hinge arch. 3 hinged arch. I will consider the case for 3 hinge arch. So we know very well what is 3 hinge arch. 3 hinge arch is basically this type of arch. This one is arch, and this rise. This is the rise H. This point is A. This point is B. And in 3 hinge arch we know very well that we have the internal hinge at the crown, and we know very well that at the crown the value of this bending moment, if this point is C, then the value of bending moment at that point it will be 0. So this is our 3 hinge arch. And if point load is unit load is moving, and say for an example if it is at a x distance from left support, that is A, then vertical reaction due to this unit load, it will be how much? VA, and horizontal reaction it will be H, and it will also have value of VB. It will also have the value of VB, and horizontal thrust as point H. Okay. Since it is a determinate hinge, so we do not need any compatibility equation. We can have the value of H. We can calculate the value of VA and VB using only equilibrium equation. So the value of VA, this value of VB, it will be simply how much? It will be simply X by L. And this value of VA, it will be how much? This one, L minus X divided by L. Okay. And if you want to know the value of MC, we know the value of H. So for H, what we have to do to know this value of H? What we have to do? We can equate this part of moment equals to 0. Summation of this part moment equals to 0. Moment at this point is 0. Therefore, moment considering MC, moment at point C, and I will write here right part equals to 0. Why I am taking the right part? Because in this right part we have to consider only how much forces? 1, 2, only 2 forces. If this one part, I can take also this part, and in this part I have to consider VA, H, and 1 unit load. So it's a very it's simply for simplicity I am taking this right part. So by equating the moment at this point C, we will have VB into horizontal distance is how much? This is basically L by 2. Okay, and L by 2 and minus H into vertical distance. It is how much? Vertical distance. It is H. Okay, this right H. That will equal to be 0. Therefore, value of H. VA value we know very well how much it is. It is X by L. So put X by L here. So this L and L will be cancelled out. So the value of H we can calculate from here, and that value will be how much? X by it will be 1 by 2H times of X. It will be 1 by 2H times of X, and we know very well that H is this one rise, and it will be the constant for given 3 hinge arch. Therefore, this plot means horizontal thrust H. It will be straight line. It will be the straight line. If I will plot the IL for IL for H. I am going to plot IL for H, and that equation, let me tell you very frankly, this equation H equals to 1 by 2H into X. This is the equation for for ordinate of IL for H. Okay, and it is applicable. It is applicable only. It is applicable only when this load is from is in segment A to C. A to C. Okay, it will not be applicable when this point load is here. Okay, so what can be the value of what will be the applicability of this equation? This applicability of this equation will be x belongs to 0 to close interval L by 2. This equation will be applicable. So when x is equal to 0, what will be the value of H? It will be simply 0, and at x is equal to L by 2, the ordinate, what I will get? I will get the ordinate as this one, L by 4H. Since this graph is basically what linear, therefore it will be the plottation for the segment AC. Since now if you want to plot the IL for CB part, then it will have same type of thing, and at point here we will get this one. So this triangle having the ordinate, at mid L by 4H represents the IL for H. So this is the IL for H for which one? 3 hinge arch. Now I would like to plot the same IL for H for 2 hinge arch. IL for H for 3 hinge arch. Okay. So we know very well that 2 hinge arch. What I am going to tell? I am going to tell IL for 2 hinge arch. 2 hinged arch. Okay. For 2 hinge arch. We know very well that 2 hinge arch, let's say this is the example. This is the example. Okay. Value L and rise same. Rise how much? Rise say it is H. Same arch I am taking here, A and B. Okay. Same. Okay. For derivation of IL for H, it can be applicable for any type of arch. It can be shape. Its shape can be parabolic. It can be circular. It can be parabolic. It can be circular. It is applicable for both, because we have not used any relation between x, this one x, and this one y. So here what will be how it can be calculated? How ordinate this equation? How that equation can be calculated? That equation can be calculated by placing this unit load by x. Okay. If this is the situation, then the value of VA, value of VB, it will be same as here. It will be x by L, and it will be how much? L minus x by L. But the value of H, since the moment at crown it is not 0 like here, we cannot apply that equation. We cannot apply this equation for 2 hinge arch. Therefore we need equation for H, and we know very well that H equals to mu y square dx divided by y square dx. So I will not go in detail how these are calculated. I will use direct result for H. For this case, the value of H, it is basically if it is W, then it is W by it is W. How much is that value? Let me check. It is W upon 8HL cube, okay, into X, L minus X into L square plus Lx minus X square. Okay, so this is the equation. This is the expression. this is the expression for here. Okay, if w equals to 1, so write it here as a 1, write here as a 1. Okay, it can be derived. In last class I have derived, so go there to see that detail. Now, since this thrust, horizontal thrust, it is the function of x to power how much? This 1, 2, and here it will be the square. So it is the function of order. It is the function of x in order 4. Therefore, we do not have IL as a straight line, because here we are getting a straight line. So here it will be the order of x to power 4. Okay, it will be the order of x to power 4. So it can be if you want to plot IL for, if we want to plot the IL for S, so definitely if at h is equal to 0, what is the value? At h is equal to 0, this put x is equal to 0, then we will get x is equal to this. At x is equal to L by 2, x is equal to L by 2, so by putting that value x is equal to L by 2, we will get ordinate. We will get the ordinate, and that ordinate is how much ordinate? Is I think by putting the value. Okay, let me calculate what will be that. Here it will be how much? Okay, let me check. It will be 25 by, this value is basically 25 by 128 L by H. This is the ordinate at this point, and since we have got that, therefore in between that segment, what will be the value? That value can be calculated. That value can be calculated by putting different value of x. Okay, what how that can be calculated? Make the table. So make the table for ordinate. So ordinate. So ordinate for h. So take value of x. Equals to 0. This value will be this h. Okay, this value will be how much? It is 0, and x is equal to say it is a 0.1 L. Okay, 0.1 L. Similarly, if we put the value of 0.2 L, if we have x is equal to 0.3 L, if we have x is equal to 0.4 L, if we have x is equal to 0.5 L, means L by 2. So that value we have calculated. This value is how much? It's 25 by 128 into L by H, by putting that value. And other ordinate can also be calculated by putting x is equal to 0.1 in that equation. So the ordinate at x is equal to 0.1, it's a 0.0, is a value 0.0613 L by H. At this its ordinate is 0.116 L by H, and here at 0.3, that ordinates after calculation it will come 1588.1588 L by H, and similarly at 0.4 L these ordinate will come to be 1860 L by H, and at x equal to 0.5 L we know that 25 by 128, that is the standard expression to have this. So at x is equal to 0, this, at x equal to 0.1 L, this ordinate will be represented by this one. At 0.2, this one, 0.3, 0.4, this is ordinate. Okay, and these are the curve. And similarly, same graph will be obtained for this side also. Obtain same type of curve we will obtain. We will obtain here also. We will obtain here also. Okay, x is equal to 0.1 L, x is equal to here, x is equal to 0.2 L. We can have that. Okay, so this is basically IL for, this is IL for H in case of what, which one arch? 2 hinge arch. This is IL for H for 3 hinge arch. Now what is the difference between these two arches? Oh, the difference is only that. Difference is only that it is a linear, it is a curve of order 4. Why it is that? Why it is that? It is because this determinacy of this this 3 hinge arch, since it is ds equals to 0, and now determinacy of this ds equals to 1. Starting indeterminacy, it is 1, so it is indeterminate and it is determinate, and we know very well that the ordinate of IL for any parameter for determinate type of thing, it is a straight line, and ordinate for indeterminate type of structure, it is a curve type of thing, and that's why this is shown here. Okay, so this is the first one thing, IL for H. Next, I would like to plot the IL for bending moment. IL for bending moment. IL for bending moment. X at any section, x is equal to A. IL for bending moment at any section, x is equal to A. Okay. So we will use how they can be plotted. They can be plotted very easily. Since we will place this unit load here, same load here, and since we have calculated the value of H as L by how much? It's L by no. It's how much? Value of X is what? What was that value of H? It is 1 by 2H into X. Okay, this is the value of H we have calculated. Okay, so we will use that expression to have a value of Mx. And bending moment at x is equal to A. What is the expression? We have the expression mu beam moment at the same point, beam moment at x is equal to A minus H into Y. And what is Y? Y is x is equal to A. Okay, what is mu and what is H into Y? H you know very well. H is this. Y is this one ordinate, this one vertical ordinate. Okay, now mu. So mu is this one, BA, BB, and unit load 1 unit load acting here at a distance of x. So this is basically figure by FBD to calculate the value of beam moment. To calculate the value of beam moment, it's the horizontal protection at any point. Okay, this point, this ground point C, this A, this B. Okay, this point C. So what will be the IL? IL for this. Now IL for this. IL for M bending moment. M at x is equal to A. It will be IL for mu. IL for mu I alpha mu minus y at x is equal to a. It is the constant thing, है ना? Let y at x is equal to a. कैसे? How you will calculate? We will calculate it from that relation 4h by L square x into L minus x at x is equal to a. For parabolic type of arc. For parabolic type of arc, it will be this type of thing. So it will be I alpha. It will be I alpha h into something constant. Say if this value is b. So it will be the I alpha. It will be the I alpha bending moment at any point x. Okay. So to have the IL for any point B, for any point, if the point A, if we are interested, if our interested point is D, this point is D, and if this is at a distance from here, okay, then the IL for B moment for this beam we have how much? We have this here, this one not in it. And what is that value? We know very well. What is that value? That value is this one. If this is A and if this is B, so it will be A into B divided by L. That is the value of. And B is what? B is basically L minus, not right B, because it will be confused from here. This is the, what is this? This is the IL for mu. This is the IL for mu. Okay. IL for mu. And IL for H. Since we have calculated the IL for H, and we know that value at the crown. What is the value of IL? What is the shape of IL? The shape of IL is this one at crown. That value is how much? This value is L by 4H. This is the value for IL for H at x is equal to L by 2. At x is equal to L by 2. Okay. This is the R. Therefore, IL for, if we are interested here, IL for H into B, then what will be that? Every ordinate we have to multiply by the same value of B. So this will be this straight line will represent the IL for H. Okay. Now if I want to calculate these values, so what will be that value? L by 4H times of B. Okay. Now I would like to calculate the magnitude of value of that L by this one. I want to calculate. So what is that? What will be that? L by 4H into B. So L by 4H into B. Put the value of B from here. Means it is x. B is the ordinate. This one. Okay. This one. It will be y. It will be B. Basically, it will be B. So put that value. It is 4H by L square into x will be A into L minus A. So some parameter will be cancelled out. This one, and this one. What will we get? We will get this one. A times of L minus A divided by divided by L. Okay, so these are the ordinate at the bed. Now, since we have to superpose, if I have the IL for mu, if I have the IL for this, and if we superpose these two, then the remaining, since this is the minus sign, therefore the remaining thing will represent the IL for M. Okay, since this value ordinate for IL into B, it is same value, this one value, since this one value is same and this one value will be same, so that value will represent at the same level, and therefore this graph will represent the IL for H into B. So this is the basically this remaining part, this remaining part is the IL for Mx at point where x is equal to A. Okay, what will be sign? Plus, minus, which one will be plus, which one will be minus, which one will be plus, which one will be minus? Definitely this sign will represent minus sign, and this sign will represent plus sign. Okay. Therefore, if point load is moving, if point load W is moving in a 2-hinge parabolic arch, okay, only for 2-hinge parabolic arch, because why we are using parabolic arch? Because we have used these ordinate, and these ordinate. Same ordinate, for same ordinate we have used that expression, so it may not be true for circular type of thing, it will be applicable only for parabolic type of arch. So if this point load is moving, okay, and if you want to calculate the maximum value of bending moment, maximum value of positive bending moment, so where that load should place in that arch, definitely it will have to place at this point. This point is D. So if maximum positive bending moment at any section x is equal to A is required, then load must be placed at where? At section itself. For maximum positive value. Similarly, for maximum negative bending moment at x is equal to A, where the load should be placed? Load should be placed at this one, at this point. This point is C, this point is basically means at point, load must be at point, load should be at point where? C. Why? It is because the bending moment is the load multiplied by the ordinate. What will be that value? That will be load multiplied by, if this value is C1, so it is W into C1, and what will be positive now? Okay, it's not C1, this will be W into C1, and what will be that ordinate? If this is D1, so it will be D into D1. Okay, so this is the maximum value of this. Okay. We can find absolute bending moment also. We can derive the value of absolute bending moment for that case also. If this point load is moving into that, okay, we can have that value of absolute bending moment. So how that absolute bending moment can be plotted? Very easily. Let me explain. Now what I am going to tell you, the value for absolute value of positive and negative bending moment. Absolute value of positive and bending moment for point load. Okay. we are going to interested to find the absolute positive and negative moment for point load W. Point load W. Okay, point load W. Since we have to find absolute, so absolute meaning is what? Absolute meaning is what? You have to locate. We have to locate a section which we have to find a section. We have to find a section in that arch. We have to find a section in that arch which will have the maximum value of bending moment whatsoever is the position of load. Whatsoever is the position of the load that we want to calculate. Basically, in calculation of maximum bending moment, we have two type of things. Basically, this graph to this curve, we will get the value of maximum bending moment, maximum positive bending moment, and maximum negative bending moment at any given section X. At given section X. Now, what I am going to calculate through this, using this IL, I am going to calculate the absolute bending moment. And absolute bending moment, we have to also find the value of the section where that maximum bending moment will occur. Therefore, first of all, we would like to calculate the value of this positive bending moment for positive bending moment. So positive bending moment, what will be that ordinate? We have told you for maximum positive bending moment, for maximum positive bending moment. Maximum positive bending moment. What is that? It will be W into D1. I have explained earlier. So this value of M max. Okay, M max. It is and what is the value of DD1? How DD1 can be calculated? How DD1 can be calculated? DD1 can be calculated. Suppose this point is D2. Okay, so value of this DD1, value of DD1. This will be D2 minus D1 D2 simply from here. Okay, and we know very well D1 D2 value is this one. Okay, and put here these are A is equal to what? A is equal to X. So in terms of X, it will be X into L minus X divided by L. This is D1 D2 and minus DD2, and how much will be that ordinate? Can you calculate? How much will be that ordinate? Can you have any idea? This can be calculated. How this value D1 D2 can be calculated? This can be calculated from similarity. Consider this point. This point is suppose C2. So consider this. Consider this triangle. Okay. Consider this triangle and this one triangle. So from similarity, we have this one C2 divided by this. So what is the value? C2 divided by this point is suppose B. So C2 into C2B equals to D1 D2 divided by what is that distance? This will be, since this is how much? This is A, so it will be X minus A. That is X minus A. D2 B. So here D1 D2 will be how much? D1 D2 will be C1 C2. This one C1 C2. It is a X times of this one, X times of L minus X divided by L. Okay. D1 D2 and divided by C2B. C2B is L by 2. So it is L by 2. Okay. Into x minus a. So this is the value for d1 d2. Now put that d1 d2, put that. So maximum m, कौन सा, which one, positive, is equal to w times of, take common here, so it is you can take also common as x times of L minus x by L also, then you will get here it is totally 1 minus x L minus x by L. Okay, you have taken common, that common outside, so it will be 2 times of x minus a. Why you are writing x minus a? This will be L minus, and this is a equals to what? A equals to x, so it will be how much? L minus x. You have to write here L minus x. L minus x. Okay, so it is how much? 2 times of L minus x divided by how much? L. Okay, is it correct? Okay, it's a correct. So it is a w x L minus x divided by L. Take L square here, so it's a L minus 2L minus plus 2x. Okay, so it is the w into x L minus x, and here it is L plus 2x divided by L square. This is the value of maximum m, part 2, maximum part 2. So after having this, okay, I think it will be minus actually. Okay, now, so this is the value of maximum. Which one is this? Positive. So for maximum value, for m max means for absolute value, absolute bending moment, what we will have? Del m max by del x equals to 0. And if we are going to differentiate this, so this 0 equals to w by L square, and we will have del by del x times of Lx minus x square, and here minus L plus 2x. Okay, and now w by L square, and it is a del by del x, it's minus L square x, and this is minus means plus x square L, now plus L square x minus 2x cube, this. Okay, now it's a w by L square, okay, w by L square, here it will be minus L square, this one, okay, so it is a how much? This one is, I think, a mistake, L square x plus, okay, yeah, this one will be plus 2, right? Okay, so it is basically 3 means plus 6L x, okay, and minus 6x square equals to 0. So we will have 6x square, 6 square minus 6Lx plus L square equals to 0. Now if we solve that equation, then we will have value of f, two value of x, one is 0.789 and another will have 0.211, L. Okay. These will be the values. These will be the values. Since we know very well that that expression is applicable only for A to C, means value of x cannot be more than L by 2. Therefore, that value will not be correct. So, value of x we will take at 0.211 L. Now, if you want to find that absolute value of bending moment, then we will have to put x is equal to how much? X is equal to 0.211 L. So after putting these values, after putting the values of 0.211 L, 0.211 L in this expression, we will get how much value? We will get value as maximum m, max, and positive. It will have W. After putting these values, we will have, I am writing here directly these values, and this value will be these values will be 0.096 WL. 0.096 WL. After putting here x is equal to 0.211, we will get this one value. So this is the absolute bending moment. Absolute bending moment and positive. And where that bending moment is will occur? It will occur at x is equal to 0.211 L. From where? From point A. Okay, point A is this. Same type of thing will also be occur if the point load is moving from this side, means from B. If it is as x, then we will get the same result. So if we will plot this absolute bending moment, then we will get this type of graph. We will have that type of graph, means at x is equal to 0. This one graph, since it is a parabolic. Okay, and this maximum value, it is a how much? 0.096 WL, and this ordinate how much? 0.096 WL, and these values how much? 0.211 L, and this value will also be 0.211 L. This is absolute. This is the figure for absolute bending moment for what? Positive. Okay. Similarly, you can also plot the expression for absolute negative bending moment also. You can also have the maximum. Should I erase this? Okay. No, here. Right. Now next I am going to plot this absolute bending moment. Which one? Negative. We know very well that this value is how much? For that, point load should be at where? At point C, means at crown. So it will be CC1. It will be CC1. Okay. So similar, it involves the similar procedure. So the value of CC1, this one CC1. What will be that value? CC1 will be what? This entire C2 minus C1 C2. Okay. Value of this CC2, it is same, x into L minus x by L, and this one value C1 C2, this one value we can calculate it from similarity, and for that similarity we use these two, and this one triangle for this one value. Okay, and this total value we know very well, and this diagram can be used. Okay, this diagram can be used Okay, so this one this one divided by this one, I am writing directly value of this d1 d2 means x times of L minus x divided by L. Okay, this is d1 d2 divided by this one distance. This one distance is how much? X divided by x is equal to, okay, is equal to this C1 C2 divided by this one distance. How much is that? L by 2. Okay, so L and 2 will be here. So this x will be cancelled out. Therefore, value of 2 C1 C2 will be L times of, and how much is that value? L minus x divided by L. So L will also be cancelled out, for it will be simply L minus x. Therefore, C1 C2 will have L minus x by 2. Okay, is it correct? Let me check. This one, x times of L minus x divided by L divided by this one and divided by this distance means x. Okay, x is cancelled out, no problem. This one distance C1 C2 divided by this is L by 2. So this is okay. So C1 C2 is 2 C1 C2 equals to x cancel out L minus x by L. Okay, and this one x L minus L. Okay, this is correct. Now what is the value of which one? CC1. Now we can calculate the value of CC1. We can have the value of CC1. So it will be simply CC1. What is that value? That value is simply x times of L minus x divided by L. So take L minus x as common, L minus x as common, then we will have here x by L minus this one, now 1 by 2 only. Okay, so if we will take this also, 2 also common here, so it will be 2 and here it will be minus 1. So we will have L minus x by 2 times of how much? L 2x minus L. Okay, that we will have. So what is the bending moment? What is the absolute negative bending moment? So the ordinate for absolute bending moment and minus, it is a W times of CC1, ordinate CC1. Okay, this one, put this value. So it is basically L minus x, W times of L minus x into 2x minus L divided by how much? Divided by 2L. Okay, and it is the function of how to power x means x square. So it will also be parabolic. It will also be plot in terms of x as power n by 2. Okay, so simply if you want to find the section where this absolute bending moment will be possible, so differentiate that equation m max with respect to x equals to 0, and by dividing this we will get 0 equals to w take del by, take this constant thing outside, w by 2l into del by del x, del by del x as how much? L means 2lx minus L square, and this one minus 2x square. Okay, and plus Lx. So we will have 0 equals to 2lx. It means with 3lx. Okay, so this w divided by 2l, no need to write here. So this one and this one, it is 3lx means it will be 3l only. Okay, and L square is 0 now, so it will be minus 4x. Okay, so the value of x we will have how much value? It is the 3l by 4, 3 by 4l. It is a point how much? So we have got x is equal to 3 by 4L. Okay. Now we by putting this value x is equal to 3 by 4L in this expression, we can find that value. Okay. So by putting that, we will get absolute bending moment minus negative means W by 2L, and here it is how much? It is basically this one. This. Okay. I am writing this in this manner. Take 12 as common. No. Take this one. Okay, write this in terms of 2lx minus x square. No. Okay, no problem. Take common as L, then you will get 2x minus L. Okay, and minus here you take x as common, then you will get how much? 2x minus L. Okay, so this value comes to be W upon 2L times of 2x minus L times of L minus x. Okay, now put x is equal to this is what? This is absolute bending moment. No, this is only maximum bending moment negative. Equation is this. Okay, and here if you will plot this equation, and if you will plot this equation, then definitely it's a function of x to power x square. Definitely you will have this curve type of thing. You will have curve type of thing. Now absolute bending moment negative value, it will be at x is equal to how much? 3 by 4L. So by putting this W by 2L into x, it means 6 by 4L minus L. Okay, and it is L minus x, it means 1 by 4L. So what you will get? W by 2L into 4, so it's a minus 2L by 4. Okay, and it is L by 4. So you are getting this minus cancel, and it will be minus W L by 16. Okay, so this is the absolute bending moment, negative bending moment. It is at x is equal to 3 by 4, and this value is minus WL by 2. Now if you can plot this, then how it will be possible? It will be possible. This suppose this point is AB. Total distance is how much? Total distance is, this is how much? This is total L. This is total L distance. So from this here you will get this bending moment 0. It will be 0 at here, and another it will be 0 at x is equal to L by 2. Okay, and since here it will be parabolic, and absolute bending moment is a WL square by WL by 8. So this value WL by 8, WL by 16, and that distance, this distance is this distance from here, that distance is how much? 3L by 4. Okay, so this distance it will be L by 4. Okay, so here look this diagram. Point load has to be taken here. It means it is moving from A to B. If the point load is moving in this direction, from here it is moving, point load is moving, this unit load is moving here. If it is moving in that direction, then you will get the same thing, same expression you will get, and bending moment will be 0 at here, and the ordinate you will get, maximum ordinate will get x is equal to how much? X is equal to L by 3L by 4, means this one distance will be L by 4, and this ordinate will be how much? WL by 16. And since this is negative value was negative value was there, this was negative value, so it is the absolute, it is a diagram for absolute bending moment negative. Okay, so this bending moment is L by 4 distance from A, L by 4 distance from B, and this value is given by this. Okay, now this was the case for which one? Point load. Okay, similarly this can also be applicable, this bending moment equation can also be used for UDL also, So if absolute bending moment is for point load, just remember point load. Okay, for point load, for such type of thing you have to read this diagram have to be remembered for other two type of question. So now case 2, if UDL is there, if moving load is UDL. Okay, moving load is UDL. So in this expression, in this arch, if UDL is there, this L, okay, same rise crown C. If it is more than length of this UDL is more than L, means sufficient that can be occupied sufficiently. So for this case, maximum negative bending moment will be what? This for UDL case, since for UDL case bending moment will be W into covered area. Okay, so the if for positive bending moment, if load where this UDL should occupy in this place. Okay, for positive bending moment, what will be that value? Is the area of if this point is D, if this point is suppose this one point, suppose it is this point is suppose O. Okay, so it will be the area of this one. So area of what I should write? D, O and B. Similarly, negative bending moment, maximum negative bending moment, it will be W into covered area. Covered area will be how much? Area of this one type. It is say this one. It is this point is suppose A, so it will be A C O. Okay, triangle, area of triangle, this one. And for this you have to locate this point. First of all, you have to locate this point and you have to find the ordinate, and here you will analyze that both positive and negative bending moment will be same. Why it will be same? Let me explain here. If this is L by 2, then if it is L by 2, okay, and this crown C, and you know that this value is how much? X times of L minus X by F, and if at any point D we will have this ordinate, this is basically positive, this is basically negative. Okay. Negative. Okay. So and what I am taking this point is as taking as point O. Point O. Look here. These two area, this one area and this one area. Is it same? Is it same? Means what I am telling to you is this one area and this one area. Is it same value? Is it same value? No? This point is since A, this point is suppose B. Is it same value? Of course it will have same value. Why it will have same value? Because this is the midpoint. So this area, what is that area? What is this one area? What is the value of this one area? This one area is this total minus this one. Okay, the total. This is the basically area of is what A C B minus area of this one AOB. Okay, this is that area. And what is that area? This area is area of ADB minus area of this AOB. Okay, since this one area they are the same thing, and this one area ADB and ACB, area of ACB and area of AD triangle, area of triangle ADB, area of triangle ABD, since both will have same. Why it will have same? ACB, look here, ACB, what is distance? L distance, have ordinate is this, so it is how much is area? Half into L into this one distance, same, x into L minus x divided by L. Okay, this is the area of this, and what is that area? It is half into L. L is same. Okay, what I am okay, and value of x L minus x by L. So this one and this one is the same area. Therefore, this for this case, for if moving load is radial, then negative and positive value both will have the same ordinate. Both will have the same ordinate. Okay, both will have the same ordinate. So how you will calculate? How you can calculate? So you can calculate calculation of this area ACB. ACB is no problem. This is the area. Now you have to calculate AOB. This one AOB, and for that what you need? What you need? You need this one ordinate basically. You need this one ordinate. What will be that ordinate? What will be that ordinate? That will be your question. What will be that ordinate? This will be the question. If you know this ordinate, then you are able to find the value of the area. If the value of area is known to you, then positive and negative bending moment can be calculated, and after calculating that value, differentiate it with respect to x, find the value of the section where the absolute bending moment will be there, and after having that value you can plot that diagram also. Okay, and you know very well what is this distance. This distance is what? X, because this is a section, so this will be L minus x. Okay, so for this case I am not going in detail. Because it involves simply mathematics, and I am giving you the direct result. I am giving you the direct result, and the result is basically for this case, for UDL type of case, it has this type of thing. It is L by 2, this L by 2. After calculating this area and multiplying with that, you will get equation for maximum bending moment, since it is area same, so same will be. And after having that area with differentiation with respect to x and equating that, you can have that value of this ordinate and that ordinate. Okay, here from here also this ordinate and this one ordinate, that you have to remember, and this value after calculation, its value is 0.234 L. This value also 0.234 L, and the maximum value of bending moment, it is 0.01, is 0.01833 WL square by 8. This ordinate also has same value 0.01833 WL square by 8. Let me check. 0.01. Okay, 0.01833 WL square. So this is the plot for absolute bending moment. Positive and negative. Just have the same value, positive and negative bending moment, and it will occur when at what section? 0.234 L from either from A or either from B, and this value will be same. This one value means positive and negative, both will have same value. So for objective type of question, that value you have to remember. Okay. Now after that I will discuss, I will plot what I have done right now. I have plotted the IL for both 2 hinge and 3 hinge arch, and after that I have plotted the IL for only IL for MX only for 3 hinge arch, and we have and its application for point load and UDL. I have discussed it. Okay, where the maximum bending moment, maximum positive bending for point load, where the load should be placed for positive bending moment. I have told you that for positive bending moment, point load must be at the section. From this diagram must be at the section, and for negative, for maximum negative value, the point load should occupy at the crown point, and the value will be this one. Means C. If this point is C1, then it is this one ordinate, and for a positive bending moment, it should be placed at the section itself. This value. Okay, and for UDL, if UDL is there, then it should for positive bending moment, it should occupy in this place. For maximum bending moment, either in this place or in this place, it will have the same meaning. Okay, it will have the same value. Now I will plot the IL for MX, IL for bending moment at any section for 2 hinge arch. For 2 hinge arch, I would like to I am going to plot the IL for this X is equal to A for which one arch? 2 hinged arch. For 2 hinge arch. Okay, for 2 hinge arch. Okay, so this is the that was the equation, that was the plot for IL for MX is clear. For what? 3 hinge arch. Okay, now for 2 hinge arch, what will be the difference? Since this one arch, I have this one arch, same length L, rise L, rise H, crown C. It does not have any internal hinge at the crown. And for that, and we know very well that bending moment at any point X, it has mu X B moment minus H into Y. And for that we have calculated H. Okay, and that value of H we have calculated what was that value? Value of H when the point load 1, unit point load is at point X, then that value, what is that value? Let me write again. That value is 5 by 8. 5 by 8 W means 1 divided by HL cube, 1 by HL cube times of X, L minus X times of L square, plus LX minus X square. Okay, this is the ordinate for H, this one. Okay, so IL for MX will be IL for this one B moment, IL for H. So IL for this one, IL for H multiply by ordinate at X is equal to A. Okay, so it's very simple. For B moment, you know what is B moment. B moment, we will have VA and VB. Okay, value of VA and VB reaction. VA, that will be L minus X by L. It is X by L, and point load is here at this X. So it's IL for mu. Do not have any problem. It will have this. It's a very simple, and its value will be how much? Its value will be X into L minus X divided by L. Okay, so this is the IL for mu. Now IL for H, since we have plotted, since the ordinate for H, if the ordinate for H we have plotted earlier, it's 25 by 128. What was that? It was IL for H. This one ordinate, it was 25 by 128 H by L. Okay, H by L or L by H? Let me check. It was L by H, not H by L. Okay, so it is L by H, and curve type of thing we have got it. So this is the if this is the IL for H in case of two hinge arc, then what will be the IL for H multiplied by Y at X is equal to A. X is equal to A. For parabolic arch, if this value for parabolic arch at certain section, suppose this section D, at certain section, if this is A, then this ordinate I have told you, suppose this is B. Okay, so this will be the constant thing. So when it will be multiplied with constant, then you will get this type of ordinate. So that will represent this type of thing. Okay, that will represent this IL for H multiplied by this. So since it is the bending moment is the summation of these two, so mu, IL for mu we have plotted. Simply by superposing this, we can have that value. Okay, and this one ordinate will be how much? It will have how much? It will have 125. No, it will have 25. It will have this one. Let me write here: 25 by 128 H by L times of B. Okay, this one will be H by L by H times of B. Okay, and it will have curve type of thing. And here, look here. This one ordinate and this one ordinate. It is not the same. And since it is minus, so the resulting will be this. So this will be the IL for bending moment X is equal to A for 2 hinged arch. For 2 hinged arch. Okay. Now look here. Okay. Look. Compare this one diagram and this one diagram. What you are getting here? Since ordinate of hy moment, it is the order of how much? It is the order of x is equal to order of x in terms of n 1, 2, 4. N is equal to 4. It is the order of n is equal to 4. Therefore, it is a this idea this it is a curve type of shape. In here, it is a straight line type of thing. Why it is a straight line? Why it is curve? It is because only that 2 hinged arch is indeterminate. Okay, this is this was for determinate type of arch. Okay. Now, if and what will be the sign of this one will be treated as negative. This one diagram, this one will be negative, and this one will be positive. This one diagram will be positive. So if the point load is moving in this case, okay, so where the point load should be placed? The point load should be placed for maximum positive value. It will be at the section. It will be at the section. It should be placed. It will be placed at the section. Okay. Here I am our point D. I have taken the point not here point D. It is here point D. Okay. So do not confuse that. So for maximum positive bending moment, in case of point load, it should be placed. And what will be that if this is D, if this is D1, so the value of bending moment, value of maximum positive bending moment, it is same as in case of earlier. As in earlier case, it was it will be W into DD1. Okay, W into this DD1. And what will be the value of? Let me write here. So case one for point load. What I am going to tell you, maximum positive bending moment, for point load W. Okay, load must be at where? At section itself, and its ordinate its value will be W times of D1. How you will calculate? W you know very well, and D1. How you will calculate that I want to tell you, because in numerical question that will be used. Okay, D1. So if this value is, suppose its value is D2, so DD1 will be D2 minus D1 D2. Clear? And DD2, what is the value of this one? What is the value of D2? Can you tell me? This value is this. It is written here. It is simply x L minus x by L. Okay, that has been written here. And what is the value of D1 D2? What is the value of D1 D2? This one value. Okay, this one value. What is that value? This one value. This is the ordinate for this. This is the ordinate for H into Y at B. Here I am writing here S B. This is the ordinate of H into Y. So D1 D2 will be B times of equation 5 by 8 1. It is H L cube into X L. What was that expression? X L minus X times of L square plus Lx minus X square. Okay, at X is equal to what? A. This will be the ordinate of D1 D2. So by calculating this ordinate and multiplying with ordinate at x is equal to this one ordinate, you will get d1 d2, and after getting that value, you are able to get this one d1 d2. So the value of the bending moment can be calculated very easily. Maximum positive bending moment can be calculated. Okay. Now, if you are if maximum negative bending moment is required at any section, X, I am talking here at any section A. Okay, at any section A, I am talking here. Okay, at any section. I am not talking for absolute. Okay, I am not talking for absolute. Okay, here if the absolute value is required, if, so you know very well, absolute value is free from the section. It means you have to locate also a section where that value can be possible, where that maximum value can be possible. So after having that, okay, you have the expression in terms of this, differentiate it and find that value. Okay, it's a basically involvement of the multiple algebraic calculation will be there for calculation of that. Okay, here in books the diagram for absolute bending moment has not been plotted because it's a very complex type of graph, will be very of order more than that. That's why we do not have the graph. We can manually calculate that if it is required. Okay, since same thing can also be done for maximum negative value. Okay, but the problem here is that you do not have a specific point where that negative bending moment will occur. You do not have for that negative bending moment, you do not have any specific point where that can be possible. That can what I want to say, it means the point load, where the point load should be here or here or here. Okay, where the point load should be here. If the point load is here, then what is the value of maximum bending moment? It will be multiplied by that. Okay, if the point load is here, then it will be multiplied by that ordinate. If the point load here, it will be multiplied by that ordinate. Okay, are you getting what I am telling to you? Now, out of these ordinate, which one will be the maximum ordinate for this bending moment? It will have this ordinate must be maximum. This ordinate must be maximum. It will be W into maximum ordinate. Maximum ordinate. It will be the maximum ordinate. Say if it is y1, say it is y1, y2, y3. It may be y1 maximum ordinate of y1, y2, y3, and so on. Okay. How you will calculate? How you can calculate that these values y1, y2, y3 is very simple. It's very simple. It's very simple. How? Expression for this equation, expression for this graph, you know very well. What is that? This is the expression. This is where is that? That is that. Yeah, this one. Expression. This one expression is for what? H. Okay, H. H into B multiply. This is the expression for this. Okay, and this expression you know very well. Differentiate. Find the value of bending moment x here. Okay, what is the bending moment x here? From here. Take any point x. Take any point. Choose any point x from here. So the bending moment you know very well. It is how much? It is mu minus h into y. Put the value of x in terms of this y constant. Differentiate this and equate. Differentiate with respect to x, equate 0, find the value of the section where the point load should be there, and now put that value of x in this expression to find that value of the maximum negative bending moment. Okay, in the same procedure as we did in case of 3 hinge arcs, for absolute bending moment you can do the same procedure. Here the plottation of graph will not be so simple, that's why that has not been plotted here. Okay, after this, what we did, we have plotted IL for H, IL for M, for 2 hinge and for 3 hinge. Now I would like to plot the IL for other type of forces. What are other type of forces? First of all, I would like to plot IL for normal thrust. I alpha normal thrust, and you know very well that what is the value of normal thrust. I have told you earlier that this value of normal thrust, it is basically S times of sin theta cos theta. Is basically let me check which one is that value. Let me check normal thrust. It was normal thrust. Let me check. It was this one. This was normal thrust, no? So this component was how much? Vp HP. This was HP, okay, and this was value theta, slope at this point theta. So the component of H, component of this HP, that will be HP cos theta, and here it will be HP sin theta, and component of VP along that, this angle will also be theta, so it will be VP cos theta and plus here VP sin theta. Okay, so the value of n here is this one is n, so it is SP cos theta plus VP sin theta. Here this point is basically what? This point is A. Okay, I have told you earlier, so just I am writing here. And normal thrust is this, and radials here, suppose this right is use this symbol as S, and this is HP sin theta plus VP cos theta not plus, it will be minus. Okay, and in that convention we have taken that upward direction of this one, and this one I have taken as normal thrust. In many books the direction may be reversed, so it can be also written as VP cos theta minus HP sin theta, for do not confuse that. Okay, now plottation for these two is very simple. Plottation for these two is very simple. Now you must know what is the this VP. What is VP? If you want to plot the IL for these two, so you have to think of that VP. VP is the basically vertical force. VP is the vertical force at this point. This one part. This, suppose this point P. Okay, and this is the basically segment of this one. A. This is P. This is P, and this is basically this part is B. So you have taken these two parts. Okay, you have taken here after making a cut. You have these two parts. So here, if this is VP, so here this for this part VP will be also there. Okay, so which type of nature it has? It has the nature at point P. It has the nature of shear. Okay, of shear. So if you want to plot the IL for n, then it will be what? It will be what? IL for H. HP is what? HP is always yes. IL for H into cos theta plus IL for VP. IL for VP into sin theta. And you will know very well what is the value of cos theta, what is cos theta, and what is sin theta. Both are constant. These two are constant, and we have plotted the value of IL for H and value of VP. IL for VP plotation is very simple, no problem. How these can be plotted? So first of all, consider this segment as a VP. As a beam part, consider a beam part. Why I am writing it as VP again and again. Take again. I have taken as VA. This part VB. So this is VB, and P point. Suppose P point is here, so I have taken this. Okay, take that as a direction of the force, VP. So IL for VP, what will be that? This is determinant type of thing. So you will have this. Okay, this is the IL for VP. And what is that ordinate? You know very well. You know very well. What will be that ordinate? Okay, do you remember? Okay, if you are not remembering, I am just giving you in a very simple, in a very fast manner. This sense for plotting this value of angle and this value of should be same. Suppose this is y1, this is y2. So the slope here it is suppose this distance is also at x. Okay, so y1, this slope means y1 divided by this one distance x equals to y2 divided by this one distance. This one distance will be how much? L minus x. So L minus x. So what you will get? Y1 equal to, you will get y1 is equal to L minus x divided by x into y2. Okay. Now since y1 plus y2 is what? Y1 plus y2 equals to 1. Okay, that should be 1 according to Muller-Wurth law principle. So after putting that, you will get y2 times of y1 means L minus x divided by x plus 1 equals to 1. Value of y2, it will be take x common, L minus x plus x equals to 1. So this one will be cancelled out. No, therefore value of y2 will be how much? X by L. So this value is y2 equals to x by L. So if it is x by L, then it will be L minus x by L automatically. So this is the IL for, this is the IL for VP. This is the IL for VP. I have told you in a very detailed manner. Okay, so finally we have to write this it as L minus x by L, and this one factor as x by L. Okay, if this is the IL for VP, okay, let me erase this now. No need to. Yeah. If this is IL for VP, okay, this is the IL for VP, then what will be the IL for this one? Entire VP is of sine theta. That ordinate, simply, it's very simple. That ordinate must be multiplied with which one? That which one? That will be sine theta for this case, for n. Okay, and this ordinate should also be multiplied with sine theta. Okay, that's that everybody. And HP, for HP, okay, for 2 hinge arch, yes sir, for 2 hinge arch, it is what? For 2 hinge arch, for 2 hinge arch, yeah, IL for H, IL for H for 2 hinge arch, and IL for H for 3 hinge. Here I am making IL for H 2 hinge. Okay, for this one 3 hinge. Its ordinate is how much? Its ordinate is L by 4H. It's a linear type of thing. Okay, and for 3 hinge we have calculated that its ordinate is 25 by 128 L by H. Okay, and it has a parabolic ordinate. It has parabolic ordinate. Ordinates are on here. Okay, so if you want to make plot for HP into cos theta, then what you have to do? For 3 hinge arcs, that have to multiply by cos theta. That for cos theta. Okay, for 2 hinge, for 3 hinge, it should be multiplied by theta, and for this one 2 hinge, it should be multiplied by cos theta. Okay, very simple. That's very simple. Now you can plot IL for n normal thrust for 3 hinge. Means what you have to do? You have to add up this one and this one. You have to add up this one and this one. Okay, and for this is for 3 hinge arcs, and for 2 hinge arcs, what you have to do? You have to add this one and this one. Okay, to get this one. Okay, since this sign is plus, you have to care that this is both. This is basically positive. This is basically negative. Okay, IL for H. So this is positive. This is positive ordinate. Okay. Therefore, you have to take care, one more care. One more care is what? Since this sign is plus, therefore you have to take reverse of that. What is the meaning of reverse? What I am telling to me, I am telling is that since this sign is plus, therefore means I am telling this type of thing. means take this value as x by L and this L minus x by L, means this one as a negative part, this one is positive part. Reverse of that and add up this. Okay, for IL for H, IL for N for 3 hinge arch, it will be summation of these two. It will be summation of these two, and IL for 2 hinge arch will be the summation of this one. Okay, this one. No, no, and the remaining thing will be the required ordinate for normal. Similarly, same type of thing will be required. Same type of thing will be required for this also. This is now. This is which one radius here? It is IL. Since it is IL for HP into sin theta, therefore that ordinate for 3 hinge arch, it will be multiplied in place of sin theta. Which one? It will be multiplied by in place of this. It will be multiplied by sin theta. It will be multiplied by sin theta. Okay, and that ordinate should also be multiplied by. And that ordinate will be multiplied by, since it is cos theta, so it will be multiplied by cos theta. It will be multiplied by cos theta. Okay, we multiply by cos theta. Now since this is negative sign, okay, so you need not to worry, add up these two. Okay, so here for this one S is this one radius here. So now for this case, for 3 hinge arch, it will be the summation of this one. It is the summation of this one. Okay, it is the summation of this one. It is the superposition of this one, and for 2 hinge arch, it will be the summation of these two figure. Okay, is it clear? Now I am making the neat and clean figure. Now I am going to make the neat and clean figure. Okay, so I should erase here. I should erase this. So here I am making for basically first of all 3 hinge arch. 3 hinge arch. Okay. First of all for N, for M, IL for N. So first of all I have to make this one, means HP into cos theta. So the IL for HP into cos theta, this ordinate will be how much? L by here I am writing here. That I should write here as L by that part. I should also erase that part. I have to write. I should write L by 4H into sin theta. Okay, this part H. This is straight line. What I have done? This is the IL for HP into cos theta. Now I have to make VP into sin theta. Since this sign is how much? Since this sign is of positive nature, therefore we have to reverse of that. I have told you. So at point X, suppose this point is X here. So here this type of thing I have to make. Okay, I have to make this. And what will be that? What will be this ordinate? This ordinate will be x by L. This will be x by L, and it's a sin theta. So it is sin theta. Okay, it's a sin theta. Now, and this will be this. And what will be this ordinate? This ordinate will have which one? L minus x by L into sin theta. Okay. So this is the required diagram. For IL for N. Okay. Similarly, here if IL for N is required for 2 hinge arch. Okay. Here I am making is for 3 hinge arch. If for 2 hinge arch. If I am making. So for 3 hinge arch, which one we have to superpose? We have to superpose this one and this one. So first of all, let me make this one. Okay, ordinate. And that this value is how much? This value is 128 by 25 by 128 L by H. Okay, L by H into cos theta. Okay, this is the IL for this one. Okay. Now we have to make this also. So we same thing we will do here. This one. Okay. What is that value? Same. X by L sin theta. X by L sin theta. And what is that value? You know very well. This value will how much? L minus X. L minus X by L into sin theta. Okay. The remaining thing is what? This one. The remaining will be this. So this is the IL for N. Now this is the plot IL for N. This one is for basically 3 hinge and it is for 2 hinge. Similarly, we can have the diagram for which one? We can have the diagram for case B. It is what I am going to write, IL for radial sphere. IL for radial sphere. So for 3 hinges we have to make this H. Okay, this diagram. So IL for H means we have to make this one. And now this ordinate has to be multiplied by which one? This ordinate, in this case we have to multiply by this one was L by 4H into, now at this time it should be multiplied by H. Okay. Why I have multiplied by sin theta? Why I have multiplied by sin theta? Huh? It should not be, no? It should be cos theta, no? Why cos theta? Because n was HP into cos theta, so that ordinate should be multiplied by cos theta. Here it will be multiplied by sin theta. Okay, so make that correction over here. Make that correction over here. Okay, make that correction over here. Okay, because it was for n, so HP into cos theta, no? So that's why you have to multiply cos theta in place of earlier sin theta. Okay, now this is the plot for basically HP sin theta. Now VP sin theta. So now in this case VP sin theta. So we will have to make this one type of thing. This one. Yeah, this one. Okay, this is for, and what is that value? What is that value? What is that value? It will be X by L cos theta, and it will be L minus X by L into cos theta. This one, cos theta. Okay, so the required thing is this one. So the required required IL is this one. Required IL is this one. Okay. Now this is the IL for S for 3 hinges. Similarly, I have to make for 2 hinge. We can also make that. We can also make that. So it is a B. IL for SX. First of all, plot the IL for which one? H. So you know very well. It is its ordinate is 25 by 128 L by H, and which one parameter we have to multiply? Multiply by sin theta. Okay. Now same thing here for this. This ordinate will be L minus X by L into cos theta, and it will be X by L into cos theta. So the remaining thing is this. Okay, so this is the IL for 2 hinges and 3 hinges. Okay, and for 3 hinges. This diagram, it is not. It can be used for moving load. It can be moving load, but in exams the question has not been asked. Okay, but you should remember that the question are being asked for bending moment. When for bending moment at point X, and for moving load. And the questions are coming in exam from that section. And this one section is not being asked from many years. So prepare for that whatever I have told you. Okay, thank you very much.